So the occurrence of combined elements. So the reactive elements exist in combined or compound form. So the elements combine with other elements to form compounds, and that's how we find them in nature. So the more reactive an element, the more readily it forms compound. For instance, something like sodium, we only find basically reacted with something else. But something like maybe copper, we may be able to find less reacted forms of copper than sodium. Now oxygen, as we brought up in the first sort of slide, oxygen is the most abundant element in the Earth's crust, okay? So it's one of the most abundant elements in the Earth, and its high reactivity has led to the formation of many compounds of oxygen. So we have lots of oxygen compounds in the ground, and those are those mineral ores that Australia has been profiting off. So we dig them out of the ground, send them away, they get refined into pure metals, and then we have all these pure metals that we can use. And the reason we have to refine them is because we've had so much oxygen in the atmosphere and in the Earth's crust, and it's combined with all these metals to give you these mineral ores. Oxygen also exists in combined form in various silicate, carbonate, and oxide minerals. So silicates are silicon compounds, carbonates are compounds of carbon and oxygen, and oxide minerals are just, those metals bonded with oxygen. So for instance, quartz grains. So quartz is a very hard substance. I think it's about 8 on the scale of how hard it is. It's used in watches. So in electric watches, they're used to keep time because of their electrical properties. So quartz is a very useful chemical, and it's composed of silicon dioxide. Another sort of substance that's mostly composed of silicon dioxide is sand. So like beach sand is mostly silicon dioxide as well. So these are just examples of where we might be able to find some oxide or oxygen compounds. Okay. So this concludes today's lesson on the reactivity and natural occurrence of elements and chemicals. So we looked at we sort of touched on why chemicals are reactive or not reactive. And we also saw how oxygen, metals, and other elements are found in nature. Okay. So question 5, it's a long one. The Earth's crust consists of the outer portion of the Earth, which is 40 kilometers thick. The most abundant element in the crust is oxygen, with iron coming fourth at about 5%. So in the slide, we saw that oxygen is about 46% and iron is 5%. If the whole planet is considered, the most abundant element is thought to be iron, which makes up about 35% of the Earth's mass. So when I said Earth's crust, this is the Earth, right? There's like this section here, just the first sort of layer of the Earth is the crust. Oxygen is the most abundant element in the crust, but if we look at the Earth as a whole, we think that iron makes up about 35% of this whole circle, not just this annular region here, okay? So account for the difference in the abundance of iron in the Earth's crust compared with the entire planet. Okay, so why is the iron so lacking in the crust, but we think it's so prevalent in the Earth as a whole? Well, in the Earth's crust, iron is combined with other elements to form minerals, okay? The Earth's core makes up a large proportion of the Earth's total mass and is mostly iron and nickel, okay? We find less iron in the crust because it's usually combined with other things, such as oxygen and other elements. However, in the Earth's core is actually a large percentage of the Earth's mass. All of the heavy elements, if you think about how our Earth formed, it would have started as like a ball of gas, and then as that ball collected other matter, it would have started to form like a sphere. And all of the densest elements would have fallen into the center of the sphere where the gravitational effect is biggest on them. So all these very heavy elements are in the center, and so those would be things like iron and nickel. So the Earth's core actually takes up a lot of the Earth's mass. Because that very dense iron got to the core, we can see that the Earth's mass will be greatly influenced by how much iron is in the core. That's why the iron percentage is so high in the Earth as a whole, but in the crust, because the iron would have seeped inwards towards the center of the Earth, we don't see as much because it's just moved away because of the gravitational effect when the Earth was being formed.